All right, so quadratic equations. Quadratic equations, right? What do we know? What do we know about quadratic? What does the equation of a quadratic equation look like? What the equation itself? Y equals blah, blah, blah. How do you know if you have an equation that it's quadratic? Huh? Okay, so the x should be squared, okay? The highest exponent should be a 2. So they have a term with a variable to the second power. A quadratic function must have a quadratic term. It must have that x squared, okay? Now, in addition to that x squared, there may be an additional linear term, or there may not be, and there may be an additional constant term. So what do we mean by that? You've got your f of x, right? What's another word for f of x? Y. So that equals ax squared, and here is your quadratic term, the x squared. A is just a number, like 3x squared, negative 5x squared. Plus, okay, so the ax squared, that's a must. Otherwise, it's not a quadratic equation. Plus, you may or may not have an x term, bx, plus you may or may not have a constant term. So what's a constant term? What's that word constant mean? Just a regular old Joe, a regular old number, no variable, okay?
Wait, if there's no constant and no linear,
then it's, right, then it's still a quadratic. So, for example, you can have f of x equal to 3x squared plus 5x minus 7, right? Is there a linear term in that one?
Yeah.
Is there a constant term in that one? Yeah. Okay, so what if you have f of x is equal to 3x squared minus 2x? Is there a linear term?
Yeah.
Is there a constant term? No. What if you have f of x is equal to negative 5x squared?
Yeah.
No linear term, no constant term, still a quadratic function. What if you have f of x is equal to negative 5x minus 7?
No.
Now it's not a quadratic function, okay? Okay, so when we graph quadratic functions, what does the graph look like? A parabola, thank you. Okay, now, parabolas are beautiful things, okay? Why? Because they've got some beautiful features. So let's talk about some beautiful features of the parabola. Okay. The first thing is, a parabola is symmetric. All right. Yeah.
For the quadratic term, does it have to be x?
No, like it could be 5t squared.
Okay.
Yeah. A parabola is symmetric. That means you could split it down the middle, fold it over, and the left and right hand parts will match perfectly, okay? The line along which you fold the parabola, so the left and the right are matching, is called the axis of symmetry. So this thing right here is the axis of symmetry. All right?
It's that line in the middle.
It's that line in the middle. That's the axis of symmetry. Now, the axis of, okay, so here's a question. At how many points does the axis of symmetry touch the parabola? 1. What is that one point called? The vertex. Okay, that's the vertex. Now, the y-intercept, this is the y-intercept where it crosses the y-axis. All right, now, we sort of touched on the symmetry before, right? So whatever point I have to the left of the axis of symmetry, I can mirror that point to the right of the axis of symmetry, right? So this point here, let's say you go 3 units to the left and make a point. If you go 3 units to the right and make a point, you get the same point, right? So right here, 2 units to the left, 2 units to the right, you get the same point. Okay? So a little bit about symmetry. Now, okay, how to find vertex and y-intercept. Once you find your vertex and your y-intercept, oh my God, it's so easy to graph these things, okay? So let's do y-intercept. Okay, do you remember from the previous, like from 2 chapters ago, how do we find y-intercept? We say x is 0, okay? So same thing here. Y-intercept, you put 0 for x. When you put 0 for x, whatever number you get, that's your y-intercept, okay? Now, this is another thing that's super important. The vertex is negative b over 2a. Negative b over 2a. Okay, well, where are a and b and c? Right? In the equation, a and b and c.
Wait, why is it intercept on the y-intercept blah 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 c or c?
It's a times 0 plus b times 0 plus c, which means like this is 0, and then it turns into c. So if you get the equation,
C isn't a variable.
if you get the equation, it's a times 0 plus b times 0 plus c. Now if you simplify that, what do you get? C, that's what it says. So it's that or c. Okay? All right, so let's do a couple here. Okay, now find the y-intercept, the axis of symmetry, and the x-coordinate of the vertex. Okay, so let's do this. Alrighty. What am I doing? Okay, y-intercept first. Make the what? Make the x 0. So that means it's f of 0, right? Remember that function notation? Negative 5 times 0 minus 10 times what?
0.
Plus 6. So f of 0 is what? 6. So the y-intercept is 0 and 6. Okay?
Because
X equals 0, y equals 6. Okay? Now, axis of symmetry. What was the equation? Axis of symmetry, when we go up here, x equals negative b over 2a. Now, the axis of symmetry is a line, right? That means you always have to have x equals in front of it. Okay, so this is x equals. All right, so now let's go to my f of x equation. In my f of x, what is my a? A is negative 5. What is b? Negative 10. And what is c?
6.
Positive 6. All right. So now, when this says negative b over 2a, what am I going to plug in? Negative. What's b? B is negative 10 over 2 times negative 5. All right. So, okay. Most common mistakes is students just mess up on the negatives. Really? Like that is probably one of the only mistakes I get here. So x equals negative 10, right? So in the end, it's going to be negative what? Negative 1. Okay, so this is the equation for the axis of symmetry. It's just that line. So now let's plot the axis of symmetry. I go to x equals negative 1, which is here, right? X equals negative 1. And I draw a line. And look at that. You just drew your very first axis of symmetry. Congratulations, guys. All right. Should we also plot the y vertex? The y vertex. The y-intercept? Yeah. Where is that? That's 0 and 6. There we go. 0 and 6. Okay. Now, yes. Yes. So, you see how I have a point? 1 unit to the right of the axis of symmetry. I mirror it 1 unit to the left of the axis of symmetry. Right there, I have another point. Okay? Right. Now we need to find the vertex. Okay, so the vertex right? The vertex is a point, yes?
Yes.
Vertex is x comma y. Now, when you found the axis of symmetry, does that pass through the vertex? The axis of symmetry passes through the vertex. So the vertex is really -1 comma something, right? Because the axis of symmetry is going to pass through that. So when you find your axis of symmetry, you've also found the x coordinate of the vertex. Okay? Yeah. No, 6 is the y-intercept. So now I want to know, on this red line, where is the vertex? Is it -1 comma 3, -1 comma -5? Where is it? So how do I find that? You know how I find it? Plug it into where? Okay, so if you have quadratic equations, talk to Maya here. So f of -1 equals what? -5 times -1 squared minus 10 times -1 plus 6. So this is -5 plus 10 plus 6. How much would that be? 11, right? Right, times -5. So how much is this? 11. Oh my goodness, so my vertex is at -1 and 11. Who would have thought? It's not even below, it's above. Okay, Lola was. Right, but it's -1 squared. -1 squared is 1 times -5. Okay, so at 11, right there is my vertex.
Oh, it's like down.
Huh?
Oh, it's down because it was negative in front, right?
Right.
In the first step.
Okay, so now it looks like that. Okay. All right, so just by looking at the equation, could we have figured out, somebody already hit on this, but could we have figured out that it was going to be facing down?
Yeah.
Right? Because because this is negative, it's going to be facing down. Because the A is negative, it's going to be facing down. Okay. Raise your hands if you have questions. Yes.
So the axis of symmetry, the equation's already negative b over 7, so can we just make the 10 just positive?
The first time I do it, I put in as many things as I can, so like I'm not skipping steps and people can follow me.
Okay.
Yes. What is it? Why is it the same number? Why is the axis of symmetry and the vertex the same number? Because the axis of symmetry passes through the vertex, right? That's how it's defined. Okay.
So why didn't we have to do the tables in the previous chapter?
Well, because we hadn't learned this yet. So little by little, we're going to get better and better at graphing them. Okay. All right. So let's talk about maximum or minimum values. All right. So if your A is positive, right? We said that it opens up. Whoa. So if, look at this one, A greater than 0. What does that mean? When you, what do those symbols mean? A greater than 0. A is positive. So when A is positive, it opens up. Okay? So here, A is positive, it opens up. And if you see this, if this is a roller coaster, right? You're riding the roller coaster, you hit a bottom valley, and then you go up. That bottom valley, in math, we don't call it a bottom valley, we call it a minimum. Okay? Now, that graph has a minimum, right? Because that has a valley. So when A is positive, it opens up, and there is a valley, there is a minimum. But when A is negative, it opens down like this. Do we have a valley or a peak? We have a peak, which is a maximum. All right? So when I ask you this, I'm not gonna say does it have a peak or a valley. I say, okay, look at this equation. Based on the equation, can you tell me, does this have a minimum or a maximum? All right, and you can figure that out. All right, so let's take a look at this one, the next one. Yeah, no matter what, a parabola will always have one minimum or one maximum. Otherwise, it's not a parabola. All right, so look at this one. So the first question is determine whether the function has a maximum or a minimum. So let's take a poll here. Well, since today is election day, let's vote. Who would say this has a maximum? Okay, who would say this has a minimum? All right, now I need some justification. So somebody justify what you said. Okay, so what was your answer, max or min? Minimum. Why would you say?
A has to be positive.
Uh-huh.
Minimum in A is 4, so that's
Uh-huh.
it.
Right. So look at this number. This is your A. A is greater than 0, which means how does it open? Up or down? It opens up. That means it looks like this. And if it looks like this, does it have a minimum or a maximum? A minimum. If you have to stop and think about it for a while, you stop and think about it for a while, okay? Nobody docks points for thinking, all right? Now, yeah.
So when A is positive, then it's maximum.
No, it's a minimum. If A is positive, it's counterintuitive, I know. If A is positive, it opens up like this, so it's got a valley, a minimum. Okay? Now it says state the maximum or minimum. State the maximum or minimum. What point is that maximum or minimum? What else do we call that point? Vertex, right. So let's find the vertex. How do we find the vertex? Huh?
So you plug in
Negative b over 2a. So x is negative b over 2a, which is how much? I really should have left more room here. Okay, so negative b over 2a, right?
negative 24 over 2 times.
Positive 24 over 2 times 4. So how much is that? 4. So that's the x value. How do I find the y value? 3. Yes, 3. Okay? How do I find the y value? You plug it in. Y is 4 times 3 squared minus 24 times 3 plus 11. 4 times 9 is what these days? 36 minus 72 plus 11. All right. Who has a calculator? Because it's too early in the day for me. Lola's coming to the rescue. Brian, close. A second close. Huh? You got negative 25? Lola, did you get negative 25? People can do it in their head way better than I am at this point. So 3 comma negative 25. That's the minimum. Okay? Now, domain and range. No. Okay, so domain and range. Okay. Domain. Do you guys remember physically what domain was? So if I've got a parabola, right? Let's put it on the axis so it looks like a real parabola. Is there an x value when I'm scanning along the x's? Is there a value where this is not going to have a graph? Nope. Right? If I'm scanning the x, I'm going to have a graph everywhere, right? So here's the little secret. Don't tell anybody. Okay? Quadratic equations always have a domain of what? All real numbers. So domain, all real numbers. There, by the way, I showed you guys this notation for all real numbers, right? You can also say this. It's like it's an R. So basically you could do double bars R. You get it? It's like a fancy R. Okay? Now let's talk about range. All right, let's talk about range. And let's talk about range. Okay, so this has a minimum, right? Where is the minimum? 3 and negative 25. Oh, somewhere there. I'm just eyeballing a parabola. This is in no way a professional parabola. All right? Now, I'm scanning along the y-axis. I start from the very bottom. Am I beeping at the very bottom? Beeping? No, 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 no. When do I start beeping? Negative 25. And when do I stop beeping? Never. So it starts at negative 25 and goes up. How can we say that? Y greater than negative 25. Now, does it hit negative 25? Yes, so greater than or equal to negative 25. Okay? Yes. Yes. So I just sketched this parabola, and I said, okay, this has a vertex at 3 and negative 25. So it starts at negative 25 and goes up, right? So I have nothing beeping here. Starts beeping at negative 25, goes on forever. So negative 25 and above. Okay, so here's a chance to win some brownie points. You've got a function, a parabola, and it's got a maximum at 4 and 7. What's the range? Raise your hand if you've got an answer for me. Raise your hand if you've got an answer. I want the range. Yeah, back there. Okay, so he says y is greater than or equal to 7. Are we okay with this? Okay, so let's sketch this. So 4 and 7, oh, round about there. There is a maximum. If it's got a maximum, so we're sticking with our range? Are we sticking with our range? Less than? Are you guys sure? What do you think? Okay, so you've managed to convince everybody. Less than or equal to. Okay? So this is how so what pieces of information are important then to figure this out? Right? If it's maximum, this is the highest it will ever reach. So it's always below. Okay? If it's greater than equal to. Okay, so that was section 1. All right. So what I'll do. So now that we're experts at graphing, right? We learned in the previous chapters about transformations, right? That based on how the equation looks, we can get the equation. We can get the graph and we can move it to the left or the right and up or down, and we can have it dilate and stretch and compress and reflect around the x-axis and all that good stuff. Okay, so in the case of parabolas, in order to be able to see all of that, okay, you have to have the equation given to you in vertex form. Okay? Right now, you don't know how to put it in vertex form yet. That's what we'll learn in sections 2 through 6. But for the purposes of using it to graph, it's fine. I will just give them to you in vertex form. So let's talk about what vertex form is. All right, standard form was what we were just talking about. So f of x is ax squared plus bx plus c. Okay, that's standard form. Now, vertex form looks like this. F of x is equal to a x minus h squared plus k. Have you guys seen that before somewhere?
Yeah.
Oh my God, it was exactly the way we saw it in chapter 2. Okay? So that's vertex form. Why do we like this? Because just by looking at this, can I figure out the vertex? So if I have f of x, like in standard form, 3x squared minus 2x plus 5, just by looking at the standard form, can I figure out the vertex? I have to do some stuff, right? Negative v over 2a, da, 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 da. But not only h and k. So if I have f of x is equal to negative 3, x plus 4 squared minus 2, can I figure out the vertex just by looking at it, just like that? Right? Yeah, what is the vertex of that one? 4 and 2. Ah, 4 and negative 2. Remember? Okay, 4 and negative 2. So that's why that's called vertex form. And we know, right, that just by looking at that, we could also extract from that transformations. Negative, oh my goodness, we just, yes, negative 4 and negative 2. Thank you, guys. Okay. Well, because it's x plus 4, remember the one with the x in the parentheses, you always have to switch the sign. Remember? Think back to chapter 2. Okay, so this number h, right? What did that do to the graph? It's okay, so it's a horizontal translation, right? It goes h units to the right or h units to the left. So in these diagrams, the blue one is always the original, and the h either moves it to the right or it moves it to the left. Do you guys remember that? We remember this. So here, what makes it go vertically up or down? Which variable? K, right? K is called the vertical translation. And if the blue one is the actual, then K either makes it go up or K makes it go down. Okay. And what does A do? A makes it reflect. So here, if the blue is the regular, the normal graph, the actual graph, then A negative will reflect it around the x-axis. Okay, now, so the sign of A, if it's positive or negative, will cause a reflection. The value of it will determine whether there is a dilation, right? And do you remember what we said? If it's less than 1, it's going to be wider. If it's greater than 1, it's going to be narrower. So we call that stretched or compressed. So let's take a look at a few, how that works. If it's stretched or compressed. Let me see.
So if A is greater than 1, we can see a vertical stretch.
Okay.
By a factor of A.
So imagine here, okay, you've attached strings to the edge of this, okay? You've attached strings to it, and now you're stretching it. So as you stretch it, what happens to the lines? They move closer and closer to each other. So this is why we call it a stretch, okay?
Let's take a look at what happens when A is between 0 and 1.
Now,
so here we have A equals
you're going to press down on it.
0.9,
You're going to press down on it. It's going to
So
get compressed. So here we're compressing. Do you see that?
And so on. Let's now take a look at a horizontal stretch and.
Do you guys see what I mean? So if you've got the parabola, if you pull it up, you're stretching it, it becomes narrower. You're compressing it, it gets wider, right? So stretching it, compressing it, stretching it, compressing it. Let's get used to that terminology as opposed to wider and narrower. We're adding one more. I don't want this anymore. We're adding one more level to this.
This is just like vocab.
Yeah. Yeah. Okay. All right, so here we go. Let's graph these. Okay. It says to graph the parent function first. Let's graph this using, let's graph two of them and show the transformations basically. The parent functions for all of these are quadratic equations, right? So the parent function is going to be y equals x squared. Okay? So let's graph y equals x squared. Where is the vertex for y equals x squared? 0, 0. Okay? And when x equals 1 for y equals x squared, if x equals 1, what would y be? 1. And if x equals 2, what would y be? 4. 1, 1, 2, 4. 1, 1, 2, 4. Okay? Let's think about this for a minute. To get to the first point, from the vertex, how much did I go to the right? 1. And how much did I go up? 1. Okay? To get to the second point, how much did I go to the right? 2. How much did I go up? Why did I go 4? If I went over 2, why did I go up 4? Because I squared it. Okay? If I had gone over 3, how much would I go up? 9. Okay, that's another way we can do it. Okay, so let's graph this. All right, now let's show the dilation, the transformation. So what does the 2 and the 5 do? What? Right 2, down 5. Okay? Now, let's get each of those points, move it to the right 2, down 5. There's the first point. Okay?
Yeah, I'm confused why you did that.
Well, because if it's negative 2, you have to move it. If the number with the x is negative, you have to change the sign and make it positive.
Right, but we already graphed this down, that's why we didn't.
Well, because this is x squared. This isn't the translated one. This isn't the one with the transformation. Okay? Where is the vertex of the one with the transformation? The one with the 2, negative 5, right? So 2, negative 5 right here. Okay? So how are we going to get the points now? Okay, so I move, how much do I move over and how much down? 2 and 5. Do you guys see what I'm doing? Okay. Okay, so look at this. We moved each point down, over 2, down 5, over 2, down 5, over 2, down 5. And now look, it's like my entire parabola went over 2, down 5. Okay? All right, so let's do this next one without graphing the initial black one. What does the negative 1 do to what does the positive 1 do? This one, plus 1, plus 4, where is the new vertex? Where is the vertex of this? Negative 1, 4. So at negative 1, comma 4, here is my vertex, right? Yes? Huh? Okay, only the one in the parentheses changes sign, remember? The other one stays as it is. Right? Okay, so what does the negative in front do? What does this negative do in the front? Turns it upside down, right? What else does it do? It reflects it on the x-axis. So now, where am I going to put some additional points here? Okay, so remember how we said when you go over 1, how much do you go here? 1. Over 1, over 1. Okay, now, when we went over 2, how much did we have to go vertically? The square of 2, 4. Do you remember in the beginning when we had graphed here? I said when we went over 1, I went up 1, but when I went over 2, I went up 4. So from the vertex, you just go pick a side. You just go to the right one. That means you have to go down 1. Or if you go over 2, you have to go down 4. Yeah. Well, you would have gone up, but because there is a negative in the front here, that makes you go down. Yeah. Across 2, down 4. So the initial one, so the way the parabola works, the initial one, if you go across 1, you have to go down 1 unit. But if you go across 2, you have to go down 4. Why 4? Because if you go across 2, you square it and you go down 4. I'll show you another way to do it right now. Elijah, question?
So when it's in that formula, it would be 1, 1, 2, 4.
Yeah. Okay, so here's another way to do it. When all else fails, what else can you do? Can you pick points? You can pick points, right? Okay, so let me talk about that for a minute. Okay, so you have the vertex. Now, what if I asked you what the axis of symmetry is? It's the vertex. Awesome. It's the vertex. So you just say x equals, what's the negative 1? That's it. X equals negative 1. That's the axis of symmetry. Okay? That's the axis of symmetry. All right. Let's go here, and I'll do this one by picking points. What is the vertex here? 0 and negative 1. Okay? So what would the axis of symmetry be? X equals 0. Right? It's x equals the x coordinate. Now, let's do this one by picking points. So 0 and negative 1, that's my vertex. What points would I pick? What points? Remember, I pick 2 points to the left or 2 points to the right, right? So I pick 1 and 2, and I'm going to plug it in here. So what do I get here? 2 minus 1, 1. 2 times 4, 8 minus 1, 7, right? So, when x is 1, y is 1. When x is 2, y is 7. What points do I put on the right? I mean on the left. I just mirror them, right? So, here's 1, and here's 1. Okay? And there we go. You've got a cute little parabola. Okay. All right, so do the next one. Tell me what the vertex is. Tell me what the axis of symmetry is. And tell me, and then graph it. And somebody is going to come up and do it on the board for us. Well, okay, let me stop this for a minute.